Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about how to find present value for a simple annuity due. Let's start by defining what a simple annuity due is. Any annuity means, whether it's an investment or a loan, would be equal payments at regular intervals. So that's for all annuities. And then if those payments are made at the beginning of the interval, then that's considered an annuity due. And if the number of payments per year is equal to the number of compound periods per year, that's considered a simple annuity. So those are the three requirements for a simple annuity due. The formula for finding the present value of a simple annuity due is this. Present value is equal to the payment amount times, in brackets, 1 minus 1 plus I, that expression to the exponent of negative n, divided by I, times 1 plus I. Note, I is the interest rate per compound period, so you take your annual interest rate and divide by the number of compound periods per year. You might see that as R over small n, where n is the number of compound periods per year. Capital N is the total number of compound periods, so you take the number of compound periods per year, which is small n, times the number of years, which is t. This formula is very similar to the formula for finding present value of ordinary simple annuities, except that for ordinary simple annuities, you didn't have this factor. The formula was just like this. However, because it's annuities due and the payment is at the beginning of the interval, this factor adjusts the formula for that extra compounding period. Let's do a few examples using this formula. So in our first example, we have an annuity, and if payments of $20,000 are to be made at the beginning of each year for the next 15 years at an interest rate of 4% compounded annually, what is the present value of the annuity? So beginning, we know that's an annuities due, and if we're making yearly payments and it's compounded annually, those match, so it is a simple annuity due. Timeline is a nice way to represent all of the information in the problem. So we're finding present value. Here's our interest rate, and here are our annual payments at the beginning of each year, and our time is 15 years. In order to calculate present value, we need to know all of the other values. So the payment amount is $20,000. The interest rate per compound period, well, it's compounded annually, so the interest rate per year is 0.04. And the number of compound periods will be 1 a year for 15 years will be 15. Plugging these values into our formula, we get present value will equal 20,000 times 1 minus 1 plus 0.04 to the negative 15 divided by 0.04 times 1 plus 0.04. We can simplify this and this value before plugging these numbers into a calculator. And once we plug this into our calculator, following the order of operations, we should get $231,262.46 as a present value. So we would need that money put into an annuity today in order to draw $20,000 a year at the beginning of each year for the next 15 years. Our second and last example says, what amount will George need in his retirement plan when he retires if he wants to receive $4,000 at the beginning of every month for 25 years and the plan earns 6% compounded monthly? So it's the beginning, and it's monthly and monthly. So we know it is a simple annuity due. So our timeline just kind of summarizes everything: our interest rate, our payments, and our time. We're trying to find present value, so that's the formula we use. In order to find present value, we need to know the other values. So our payment is $4,000. Our interest rate is 6% compounded monthly, so 0.06 divided by 12, because there are 12 months in a year. So that will be 0.005. And the total number of compound periods, capital N, will be 12 a year, and we're talking 25 years. N will be 300. Let's plug those values into our formula. So present value will be equal to 4,000 times 1 minus 1 plus I will be 1.005 to the negative 300 divided by I, which is 0.005, times 1 plus I is 1.005. When we calculate this, we get $623,931.59. So that's what George needs when he retires, to be able to collect this amount at the beginning each month for 25 years, if the money is earning this interest rate.